Hello friends. Welcome to my YouTube channel Material Welding. Today topic is spheroidization, which is one of the damage mechanisms listed in the API 571 2020 edition, clause number 3.59. We are going to cover all damage mechanisms of the API 571 by separate videos on each topic. So please subscribe our channel to get regular updates on the new videos. So what is spheroidization? Spheroidization, or also called softening, is a change in the microstructure of steels resulting from exposure in the temperature range of 850 degrees Fahrenheit to 1400 degrees Fahrenheit, or 440 degrees Celsius to 760 degrees Celsius. At this temperature range, the carbide phases in carbon steels and carbon half-moly steels are unstable, and may agglomerate from their normal plate-like form to a spheroidal form, or from small, finely dispersed carbides in chromoly steels to large agglomerated carbides. Spheroidization may cause a loss in strength and/or creep resistance. The first picture shows the unaffected base metal of a carbon steel having pearlite and ferrite microstructure. When this material is exposed to high temperature above 850 degrees Fahrenheit, the spheroidization takes place as visible by the black area in the second picture. Let's know which materials are being affected by the spheroidization. Spheroidization takes place in all common grades of carbon steel used in the refineries. The low alloy steel such as carbon half-moly and chrome moly steel from 1 chrome half-moly to 9 chrome 1 moly are included. So basically, full range of chrome moly steels are prone to spheroidization. Critical factors for the spheroidization. The primary factor affecting spheroidization are the A. Chemistry of base metal, B. Microstructure, temperature and time exposure. If we talk about types of steel, here at first, annealed steels are more resistant to spheroidization than normalized steels. Second, coarse-grained steels are more resistant than fine-grained. And third, fine-grained silicon-killed steels are more resistant than aluminum-killed steel. Time temperature transformation in spheroidization. The rate of spheroidization depends on the temperature and initial microstructure. Spheroidization can occur in a few hours at 1300 degrees Fahrenheit or 552 degrees Celsius, but it may take several years at 850 degrees Fahrenheit or 454 degrees Celsius. So temperature is a critical factor for the transformation to occur. High service temperature means faster development of spheroidization. During spheroidization, the pearlitic phase undergoes a time-dependent transformation from partial to complete spheroidization, as shown in figure here. Detrimental effect of spheroidization. Spheroidization results loss in strength, usually accompanied by an increase in ductility, which allows for deformation at stress concentrations, along with loss in creep strength. Affected units or equipments in refinery. Piping and equipment after exposure to temperatures above 850 degrees for 454 degrees Celsius. The loss in strength may be as high as about 30%, but failure is not likely to occur except under very high applied stresses, in areas of stress concentration, or in combination with other damage mechanisms. Spheroidization affects hot wall piping and equipment in the FCC, catalytic reforming and coker units. Fired heater tubes in boilers or process units may be affected. Appearance or morphology of damage. As spheroidization damage occurs at microstructure level, it requires metallographic test for the observation. In the case of the 5% to 9% chromoly alloys, spheroidization is the process of transforming the carbides from their original finely dispersed morphology to large agglomerated carbides. Prevention and mitigation of spheroidization. Spheroidization is difficult to prevent, except by minimizing long-term exposure to elevated temperatures. Inspection and monitoring. Spheroidization can only be found through field metallography, or removal of samples for metallographic observation. A reduction in tensile strength or hardness may indicate a spheroidized microstructure. Here are questions related to exam on spheroidization damage mechanism. Thank you. Please subscribe to my channel to get regular updates on new videos.